All right, so welcome back, everyone. Today we are going to discuss Chapter 5, which is about web application concepts and how they are applicable to Shiny web application framework. And today we are going to discuss three main topics. The first is the client-server model that Shiny uses behind the scenes, how it uses the HTTP protocol to communicate between the client-server model, client and servers, and what are web servers and how they work specifically in Shiny. So the first thing is the client-server model, and we'll see an image of that on the next page. The client-server model, as the name suggests, has uh, two main things. We have a client computer and we have a server computer. The client is generally the web browser of the user who is using the Shiny app. When we are using it inside our studio is also a client. It's a browser. And at the same time, our studio acts as a server. So we have the same thing acting as both client and server. But on a deployed app, the app is or the server is running somewhere on a remote data center in a virtual computer. And the client is the user's browser that they're using to access the server and communicating with the server. Now that communication happens through the network, networking between client and server. So client sends request and server responds. And an example of that is changing slider input and getting some output based on that. If I jump to that image, I think yeah, it's right here. So this is a nice image that shows this communication between client and server. Client sends a request, for example, changing the slider input. So there is a request that is sent to the server based on the current value of the slider input. The server then recognizes that, and if we have specified anything in the our Shiny server, it will then do some calculation and then send a response back to the client. This happens through the communication via the hypertext transfer protocol. The short or acronym of that is HTTP. And here's an example with a very simple bare bones Shiny app which doesn't have anything, nothing to see, but we can see how in this bare bones app, the communication happens. So I have Bullet Cloud open in this tab, and here I have that same app. If I run it, it is running for me in a browser window, in another window that you don't see, but I'm going to open that in Firefox. So now you see another tab opened. If you don't see that open, let me know. And we
I
see
can see
that,
it.
okay, great. So we see that there's nothing here because we did not specify anything in the UI. But if I inspect it, I'm not in Google Chrome, I'm on Firefox. So the developer tools look a little different here. What we are interested in is the network tab, which we also find in other browsers, and I'm going to refresh the app so that it launches again. And now we see that a lot of messages appear in the network tab. On the left, the first column that we see is the status column that has these numbers 200 and 101. So number 200 tells us that the request that is sent has a successful response. The request that is sent here is called as get request. And if I click on one of these requests, the first one, on the right hand here, we see that it is a GET request. The status is 200, which means it was successful. And the version that it's using is HTTP version 2, and so on. So we see that there are a lot of these network requests that are happening at the same time for this very simple Shiny app where we don't really have any UI inputs and outputs. but still there's a lot of things that are communicated, and we see as we were as we were discussing before in the previous discussions, we saw that shinymin.css, Bootstrap, CSS and JS, similarly jQuery, all of these files are needed for Shiny to work, and these are sent via our server. In this case, that server is within my Polyt Cloud instance. And there's a new one, which is not shown in the book chapter. If you switch back to the chapter, here we don't see the busy indicators network request here, but here we see since Shiny version 1.9, they added busy indicators, which will show just like the waiter package and other packages that show some spinning wheels to indicate that Shiny is busy at the time. That is also now sent as a network request. So in all of these cases, we see that those are successful network requests. So what are these HTTP requests that are happening over the network? We can see an example here using the header R package, which is in this case doing a GET request for the page google.com. And when we run that, we see that there's a response, and that response is again google.com. We know when that happened. We see the status that is successful. We also see that the content type is text and HTML. Uh, so it is text, but it is HTML-based text. And then we see the body of the request. This is essentially what we see in the browser as the Google homepage. So Shiny also is sending those GET requests, and when they're successful, we get these things back. And these are at the minimum that we are sending for. If you have more things or other packages added, depending on what to do, we'll get more GET requests and the responses. Now, for any web application framework, there are certain things in the URL of the app that are required, but Shiny is different from the general purpose of web application frameworks. If you take a look at this link in the slides, here's an anatomy of the URL. So we see that there is a scheme. In this case, it could be HTTP or HTTPS. And then we see the main domain name, and we also see the port. Then if we have a document that is part of this URL, we see that as paths to the file. There could also be parameters. These, for those who are familiar with bookmarking in Shiny, this is where we see the parameters in terms of keys and values. And then if we have something within a page, in a web page, and we want to get to that heading. Let's say there are 3 headings and we want to get to heading number 2. We can use the anchor using the hashtag or the number symbol, and then with that, the name of the heading. But since Shiny does not exactly follow this pattern, we have some differences. In all other frameworks that at least I know of, they use index.html as the main web page. And that, for example, also applies to Quarto-based websites and blogs. So for Quarto, we also create like index.qmd, and then it is converted to index.html. In Shiny, index.html is not required by the user, but Shiny creates it on the fly once we launch the app. So the basic app folder should contain either a single R file that will contain both the UI and the server part, just like this app.r file, or it should contain at least two files, one for UI and one for server. And if you have other functions and modules, they should be in their own hard folder. And we also need a www folder in Shiny apps that should contain static assets, for example, JavaScript files, CSS files, and images. Even if we do not create the www folder by ourselves, if you're not adding any additional CSS and we're using just the default one, Shiny still creates this folder and uses it behind the scenes. Now, how are these web apps deployed and how are they served? How does the server work? Uh, there are many different options. The most popular one is shinyapps.io, which is generally a free service with some paid tiers where you can deploy your app, and that handles everything about this communication between UI and server after deployment. There's Shiny Server open source and the pro versions. And there's also RStudio Connect, which is now called as Posit Connect. And I don't think there's something called as Quarto Connect, or if there was before, it doesn't exist anymore. But there's something called as Posit Connect Cloud, which is a very similar service, just like shinyapps.io. I think there is a section in the chapter which is not covered in the slides. So we discussed the serving the web apps, and what is indicated here is that for serving the web apps, we need both the hardware layer and the software layer. So we discussed the software layer and Shiny Server Pro for that, Shiny Server open source as well. But the hardware layer is the virtual computers like either on cloud like Amazon Web Service or Google Cloud, or it could be your RStudio Cloud local version, which is going to act as a hardware layer. HTTP UV is an R package that, in addition to the Shiny server layer, is going to run our code. It is going to create a server when we run our app. And there's an example of that here. Let me show you that here inside RStudio. So we are creating this as an example, by the way. We don't need to do this because all of this is done by Shiny behind the scenes, but this is just for our understanding. So for example, we create an empty list and we call it as app. And I'm going to restart my session. So we first create this empty list and call it as app. And then we create a call object as part of this list, which will take a request and take a request as an input. And it will contain this list, which is indicating the status, which in this case indicates that it's going to be successful. The headers for this list contains that it is going to be text and HTML, just like what we saw in the previous example with the GET request, where we get the content type to be text HTML. So that's important because we are essentially creating HTML structure using Shiny. And we also see body equals to HTML. So for body equals to HTML, let me switch to the chapter and let's see an example of that here. So just like any web application framework, uh, you essentially create an HTML file. If I go back to this example of an empty Shiny app, and let's look at the source of this app. It's not running right now, but let's see if I can still see the source. So here is the app source, and we have seen this, I think, 2 chapters ago, where it is loading multiple files that include Shiny, CSS, and JavaScript, and Bootstrap, and jQuery, and so on. But look at the beginning of the file and end of the file. This tells us that it needs to be a complete HTML page, which contains the meta tag, it contains the head tag and the body tag, and essentially everything is wrapped in an HTML tag. So if we don't have this, browsers cannot read the page to be an actual working HTML page. So we need this structure. So to get that structure in this example, uh, if we start with a Shiny app and we only run fluid page with an empty paragraph tag, and I run this here within Shiny. I need to load Shiny first. So this is all we get. This is a container, which has a class of container fluid, one of the classes from Bootstrap, and that's it. This is not the same structure as we saw here. We need all of this, and it needs to be wrapped in the HTML tag. So since it is not, in this example, we are trying to do that. So we first create this HTML template, and we provide placeholders here for the head content and the body content. Next, we create the UI part for building on this HTML template, and we can contain this fluid page with text input and verbatim text output inside the HTML template. We give it the default HTML template from Shiny package. This will make sure that the doc type HTML and HTML, all of this is added to our fluid page. So inside the body part, we are providing this UI, which is the container containing inputs and outputs. But the purpose of doing this is so that we have a complete HTML structure that is required for the browser to recognize that it's a web page. So, so we get something similar here. And then in the next step, here we are creating some tags based on icon. So with render tags function from HTML tools, we get a list of 4 objects. It contains the head, which is required for our HTML page. So if you look at it here, this is the head part that we need. And we also have singletons. I don't completely understand what singletons are, but it's something required as part of the page structure. So Angel, if you want to add something about singletons, let me know.
I don't know either.
Okay. Maybe later in the book we'll learn more about it. Then we have dependencies. So this was previously covered by Angel, where he discussed what are different dependencies for Shiny, and all of those are needed to be there for Shiny to work. So we see, for example, style sheets that are mentioned here. So all of this is added when we render the tags, and in this case, the tags that we're rendering is the icon tag. That this is also a function from Shiny. And if we look at the dependencies of this object, this tag object, we see with render dependencies function, we see that these are the style sheets that are based on the book package. And we see the style sheet for all main.css and v for shims.main.css. So these dependencies can now be added to our HTML. And to do that, we use render document. We provide the UI, which was created above here, right here. So this is our HTML template. And we provide dependencies to it. So with HTML dependency function from HTML tools, we tell it that we need jQuery, the version of it, and the script, which is jQuery.min.js, which is one of the dependencies. And we also add Shiny dependencies here within this dependencies vector. And so based on that, we now have this HTML object. And by the way, again, all of this is done by Shiny behind the scenes. We don't need to do this. This is just for the sake of understanding. So once we render this document, it is now ready. It is now creating something very similar to what we see in this bare bones Shiny app. So we get this, and now if we use the function HTTP response and we provided the content of HTML, which is encoded here in UTF format. I don't know why this is needed, but it is needed to run this. And we run this, we see status is 200, we see content type is text HTML, we get the content back. We also see the headers, which are required. They're also added. So these are the same headers that we saw in the example of the bare bones Shiny app above.
I think the encoding is for limiting the string characters that are available.
Yeah.
I know, for example, in Spanish we have tildes, we have different letters and we have different signs. And I know that UFA doesn't support that. That's, most basic just English. And it seems that for the response, it's important to know, what characters you have available.
Okay. Okay.
I know that
Yeah.
when I have, for example, you import some data, have those tildes. If you are importing some tests in Spanish, Italian, those languages, you will need to deal with the encoding of the tests you are importing.
Okay. Okay. So in that case, UTF-8 becomes even more important then, right?
Yeah, yeah. It's because for the science. I imagine you, for example, writing in Chinese,
Mhm.
the UF doesn't work for you. But yeah,
Okay. Yeah.
that's the point. Just like simple English, no, no
Mhm.
any character, no any weird character.
Okay. Got it. Yeah. Yeah. I sometimes see that kind of error when I'm working on a package, and it's about ASCII, but here I also see UTF-8. But yeah, I got the point that you're making. Thank you. So now that we see that how the structure of the HTML is created and why we need to create it, and it's because if we don't have that complete structure, although we have the container fluid that contains inputs and outputs, browser is not going to recognize it and it's not going to show us what we need. So once we have that, Shiny then uses the HTTP UV package to serve the app. To basically create a server and then run that for us. So here's that example where the HTML that we saw, the chapter creates. Based on that, we then create this app object, which is initially an empty list. Then it has a call object, which will then contain HTML in the body. We indicate the headers for it, and the status is 200 if it is successful. And then using the start server, we now have uh, the, the local host, uh, the port, and the app that we created above because it contains our content. So this, if we run this in our studio, I tried running it here in Faucet Cloud, but I could not look at the result. But if we run it and then we run this part, get and then localhost and the port, then we'll get this result back. So we'll see that the response is the address, just like google.com example. We get the date, we get the status, we get the content type, and we essentially do get the content if we browse this URL.
I
And that's it.
imagine to make that possible, you need to have two R sessions open at the same
Yeah,
time.
yeah, yeah. That's correct. Yeah, but in the online version, in the public cloud, I couldn't figure that out. Um, yeah, yeah, I got it.
That's why maybe you in the computer you can open two R sessions at the same time with no much problem, but
Yeah,
when you are using hosting, no, not like that. I know that is another server that is open source for Shiny apps. That is Shiny Proxy. I know you have heard about it.
Shiny what?
Shiny Proxy.
Shiny proxy. Yeah, yeah, I've heard about it.
Yeah,
I
it's an
haven't.
alternative to
Have you had
Shiny
a
Server
chance to
Pro.
use it?
Nope, no, I have not used it yet.
Yeah,
I'm
I think
willing
you
to.
need to create a complete server on your own first. And if it is running, then everything should be set up like a computer, I think, and then you can deploy your app on it.
I know that it use containers to
Mhm.
isolate users, like
Yeah.
because if you just run one Shiny app and serve it to many people,
Mhm.
they will be installed each other. And
Yeah.
that's why you need a Shiny Server Pro or Shiny Proxy to deal with that. I know that people use also Apache. I know anyone is using Apache with Shiny, but I know that some people using NGS and it's like I will write in the chat because I don't know how to pronounce
And Jinx,
engines. Yes, it's engines. Yeah, I
I
don't know
haven't,
how they are using that, but I know that some people is using that as a server also.
but I think HTTP UB is always used, regardless of what you are using as a server for deployment of your app. HTTP UB is used by or by Shiny to always serve it this way. Because
Yeah,
whenever we
correct.
run the app locally, we always get this localhost, and with that, the port. If we don't specify the port, it will select it on its own, but it will look like that. It will
Yeah, I think
always
that's
look
the
like
package that make the session to be blocked.
yeah, yeah,
So that no, you are serving a Shiny app, you cannot make anything else with your session. I think that's the package that made that possible.
yeah, yeah. And yeah, on the note of different deployment options, the one that I am now using and testing is Google Cloud Run. So with Google Cloud Run, you don't have to think about scaling. It will take care of that horizontal scaling. So if you have more people using your app simultaneously, it will automatically add that many number of containers. So I haven't had the chance to actually test it completely, but so far in my small testing with my team members, it is working fine. So, but let's see with actual use of the app what happens. Um,
It's
okay,
a like light app or it's a heavy much data like
it's so I created the app using Golem framework,
okay
and then I basically created a Docker container.
okay
And so Google Cloud Run would look at your GitHub. So I
hmm
connected it. So with from my GitHub repo, it's going to take everything uh, from there and then going to deploy it. So it's essentially I tested first using Docker Desktop locally, and if it is working there, it also then works on Google Cloud Run. So so far it's working fine, and I don't have to think about scaling myself, which is great. But with actual number of simultaneous users, if we have 10, 15 simultaneous users, that may be a challenge. I don't know how it's going to work, but for now, at least, it's working.
no it's great it's a good place to start. I like to use Docker. I used the Rocket project for using the container and I know you are using that also or you are making your container from the scratch installing all the dependencies.
Now, Golem creates the Docker file.
Okay.
So it uses a Rocker, and there are two functions. Uh, I'm currently using the older one, but the newer one makes it even more simpler. So once it creates that Docker file and I test it locally, it works fine. Um, and if I make any mistake, like description file is not correct, because Golem is based on package structure. So if it is not a package, if there's any mistake there, then the Docker file is going to fail. Otherwise, it generally works fine.
Oh yeah, perfect. No, the Golem is a really good option, and most of the shiny apps, that in production use Golem.
Yeah. And there's also the other one, Rhino, which is, I heard that it's pretty great.
Rhino is great, especially JavaScript.
Oh, okay.
Like if you know JavaScript, it integrates really well with Cypress. That is another way to test Shiny apps using JavaScript. It also integrates with that framework. It uses also the bots package to call function like we were in Python. In Python you call the method. So like you take the package as an object and call your function as a method of the package using the dollar sign.
Yeah, yeah,
Um, they have that concept. To me, it seems to be really hard to start with. It's like it's no easy. It's not easy framework, but JavaScript. You know how to use also uh, SAS, like yeah, Cascade chip. That's really useful. Like more flexible. It have those two. It's to me like a more advanced, advanced framework to go over.
yeah.
I haven't used any of both. I know how to build to develop packages, but I haven't created a shiny app. That using Golang. I know that Golang will be more easier to understand my side because I know I use it using test app. That the testing part is the part that Golang have doesn't have as good as Rhino has the testing part
Yeah.
because you really can render in a browser and test after rendering because
Mm.
Shiny tests most of what I do is test the server function. If your server is, but no, basically the UI. You are more limited to test the UI part.
Very interesting. I didn't know that. That means Rhino. I should try it at least.
Yeah, yeah, no, it takes some time to really get into Rhino, but to me, it seems really interesting. I would like to work more with Rhino, but for the possibilities it has and its modularization.
Yeah, yeah, I agree. All right. Circling back to the last topic for today, Shiny app lifecycle. So this figure shows us how different components work together, how this communication happens. We previously saw just a very simple image at the beginning between the client and the server. Now this has much more details. And in the chapter, if you want to go into the details, we can see that uh, in the steps here. Uh, Let me switch back to the slides. And if I need help, I'll go back to the chapter. So the first step that happens in the Shiny life cycle is that from the web browser, the client or the user goes to the app URL. As we discussed, it has a host name, a port. If you're testing it locally, that would be localhost and the port chosen by Shiny by default. And then the client browses to the app URL and sends a GET request uh, for rendering the homepage. And so this then finds the app from, for example, from the Shiny server, if the app is deployed there, and it has the UI and the server parts, which the server is essentially going to use the run app function behind the scenes and serve the UI and server parts. Now within the UI R code, we have UI HTTP handler, and this is going to look at the body of the code. This, if I go back to that example, this is essentially referring to this part, where whatever we have created as our UI using the code we wrote in the Shiny, this is where we have, other than the main HTML structure, we have the main Shiny part. So here it looks at, it adds the remaining HTML structure using HTML template as we discussed before. And then when it is validated that it is the correct HTML template, it will, using all of these functions, render document, render tags, resolve dependencies, and render dependencies, we get our final HTML structure with all the dependencies, and now our structure looks something like this. So once we have that ready, we server now sends this HTTP response, which is the HTML body, and now we in the Shiny app using HTTP UV package, we have the WebSocket handler, which is going to take the HTTP response, the static paths. This is to the www folder, which contains all the static dependencies like the default CSS of Shiny, the default Bootstrap, and the JavaScript. Even if we are not specifying any external CSS or something, that www folder is still created behind the scenes, and any other options if we have added something. And this is then served by the HTTP UV package using the start server function that we saw before in the example. So now from the server, we have now gotten a response, and this is sent back to the client. In step 4 here, we have the client browser that receives this HTML document from the server, and then it renders that HTML to the browser, and we get, we essentially create a client WebSocket, and WebSockets are going to be discussed later in the book. So essentially, we have client communicating with server, client sending the request, and server responding with the HTML of the Shiny app. So here's that same example where we use the HTML template that adds everything that we need for our Shiny app to work. And that's it for today.
No, perfect. Thanks, Umair, for presenting us. This was a really interesting chapter to see how the protocol is working, how the shinyui is managing to communicate with each client.
Yeah, I always wondered, where does the default CSS come from? And so now I have a better idea after going through the previous chapters and this one. So it's great to know all of this behind the scenes knowledge.
Yeah. Basically, it looks just almost as like consuming an API, just that the browser is managing all those cases, like, oh, what's the port, what's the site. And the HTML is at the end the response that we are getting from that API, that is the Shiny app.
Yeah, and I think it's also mentioned in the chapter that other frameworks like MBRX and other packages that others have created in R, they use HTTP UV to serve the app. So which means that HTTP UV, although used in Shiny, can be used to create your own web framework like MBRX. Have you seen MBRX?
I have seen it before. I don't understand what's the difference or what's the advantages of, of using those web frameworks. I don't really understand why they created. What was the inspiration to
I
make that?
think I think for with MBRX, the advantage is that you can do both app as well as API. So like Plumber package. So
Okay.
Plumber only does API, Shiny only does app, but MBRX can do both because in both cases, you are going to send the GET request and the POST request. Uh, so in this chapter, we only saw the example of GET request, but HTTP request can also do POST, where we send data to the server. So in any other web page, if you have two pages, you can actually type inside the URL, you can provide the name of the page and then that will navigate to that page. In Shiny, we don't have that by default. So we don't have routing directly. We have the same page URL. It doesn't change. Locally, it will always be localhost and port. If it is deployed, it will always be the address of that Shiny app. So we don't really have if you look at the URL structure here, again, we don't have this part where we can go to myfile.html, so some other page for our app. So that's why Shiny, it doesn't have multi-page apps. With MBRX, you can create multi-page apps because you can send requests to different parts of the app and
Mm.
also get data back from those parts or endpoints.
I
So
I think you can do in Shiny. I remember in the master in Shiny there was something like
with
bookmarks.
bookmarking, yeah,
Yeah, the bookmarking part. It creates a really long
yeah,
URL
mhm,
for real. But
yeah,
I don't know, maybe the Ambiotics package make it even faster, like, oh, you can, I don't know what is why they don't use that URL, and just prefer to have that as default. I know that uh, some web apps make like that. For example, I have using my strategy for getting data and getting reports. And my strategy also is a URL that doesn't change never. And
yeah.
I don't know what frameworks they were using, to develop that app. But it's also to me the more similar app I have in my mind, like China. Oh, I doesn't matter how many folders I go,
Mhm.
the URL won't change.
Yeah, yeah, yeah. So I think that's the advantage of using MPRX over Shiny. According to their documentation, single page app will always be faster in Shiny compared to MPRX, but with multi-page apps, you have a lot more flexibility. So I think that's probably the main advantage.
Okay, got it. Okay, like you are going to make a huge shiny app with many pages. This maybe would be a better choice.
Yeah,
No, no, perfect, perfect to know. Oh, I
yeah.
think we
Yeah.
can stop